Howdy and good day, fellers. In algebra, we'll be going over CO15, which is solving a multi-step inequality. And quite frankly, like we talked about on CO14, if we cross that inequality out and write equation, we can essentially cross out CO15 and write PO10. Because up until that point where you actually care about the inequality symbol, which is when we figure out if we have to flip it, right? And then when we graph, these things, combining like terms, distributive property, variables on both sides, are straight out of solving an equation in PO10. None of that process changes. Once you get down to that final step, where you've got to isolate the variable by multiplication or division, that's when the inequality kicks back into play here. So pick one of these first four that you would like to do together. Who would like to speak for the group? Yeah. First one. 7n plus 5 is less than 2n minus 7. So if we think about this as 7n plus 5 equals 2n minus 7, we recognize that its variables on both sides, and we'd start this the same way that we'd start that. What would you be inclined to do here? To get the variable by itself? Yes? Yeah, move one of these variable terms to the other side. Now, remembering this is an inequality might help influence you. In the long run, is it probably going to be better to move our 7n's over to the right or our 2n's over to the left? Probably the 2n's over to the left. Number one is that if we move our 7n's to the right, we'll have a negative coefficient, which of course we'll have to deal with that again later. And that variable being on the right side, when it comes time to graph it, we might get confused as far as that is concerned, because typically we're used to that n being on the left side. So it's going to be better for us to subtract 2n from both sides and move it over to the left. That gives us 5n plus 5 is less than negative 7. Okay, no, that's not it. Okay, what would our next step be here? We're now down to a two-step equation inequality. You don't have to think about one or the other right now because we're not doing that sign. Erica? Subtract the 5, start with that constant. Okay, opposite operations. We have 5n is less than negative 12. And it's not until this step that we really care that's an inequality symbol, because potentially we might have to flip our symbol. In this case, do we? No. So we're just going to divide both sides by 5. We get n is less than negative 12 fifths. If you want to write that as a decimal, fine. If you want to write it as a mixed number, fine. But improper fractions work just as well. Okay. To graph this, we've got negative 12 fifths, open circle, going to the left. Okay. When it comes to checking, you do need to check it. And who remembers from last week what my favorite number to plug in? 0. So given the graph that we have here, if I plug in 0, should my inequality work? Yes. No. And this is where you just follow me and stay with me if you're able to. But 0 being over here, if I plug that in, since it's not a part of my range, I'm going into this knowing my inequality should not work. But the reason why I like 0 is because when I plug in 0 for that 7n, and I plug in 0 for the 2n, what happens to that 7n and the 2n, now 7 times 0 and 2 times 0? They both just go away, right? Because anything times 0 is 0. So why I personally like 0 is because it makes the math part of this easier. I'm left with 5 is less than negative 7. Is 5 less than negative 7? No. Did I want it to be less than negative 7? No, because I was testing a number outside of my range, so my inequality should not work. And it doesn't, so I'm good. If you tested a number over here, like -3, okay, that's within the range. If you test -3, then your inequality should work because it's part of the solution set. So, use some I don't know, smart thinking, big brain when you check your answer as far as what you plug in. Do you want to do the math with the variables, or plug in 0 so you don't have to, and then just kind of understand what that really means? Okay, but the point is, the process of solving this inequality was exactly the same as an equation until we got down to that division step and then the graphing. Okay, pick another one on this front page, Brent. The third one, that fraction and variables on both sides. Let's move the page on that. Okay, so when you've got a fraction as a part of an equation or an inequality, if you're able to, I recommend defractionizing, if that's even a word, that term first. So we have n divided by 5 is greater than 8n minus 14. How do we get rid of that fraction on the left side? What? Multiply by the denominator, in this case 5. And on the right side, what's being multiplied by 5? What? The 14, yes. Elise? And the 8n, the whole thing. When you multiply an entire side of an equation by something, you need to make sure that you're using parentheses. Which means we can, set this up. The 5's cancel out there. But we have n is greater than 5 times 8n minus 14. We actually end up needing to distribute here to multiply the entire side of the equation by 5. Yes, Elise?
Could you subtract 8n on both sides first?
If you do that, then you end up with n over 5 minus 8n is greater than negative 14. So you've got two variable terms that you can't combine the way they're written. So then you might have to do common denominators. Yes, you can, but it gets a little more messy. Okay. So to distribute, the 5 goes into the parentheses. Our left side doesn't change. 5 times 8n is 40n. 5 times negative 14 is negative 70. Now we've got variables on both sides. So what do you want to do? Math gives you options. We can move our 1n over to the right side to keep our coefficient positive, or we can move our 40n's over to the left side to keep our variable on the left side. Each has its pros and cons. What do you think? Who wants to make a decision for the class? Audrey? Sure. So moving the 40n's over to the left does give us a negative amount of n's on the left, but having that variable on the left side is how we're used to seeing it. We still don't flip our sign because we haven't done any multiplying or dividing yet by a negative number. You recognize that we will need to do that here. You'll probably also realize that things don't work out evenly, but that's okay. Okay. Dividing both sides by negative 39 now to get n by itself. The symbol does flip, becomes less than. And negative 70 divided by 39, the two negative signs cancel out. So we can write it as 70 39ths. If you want to do a decimal, you can. If you want to write it as a mixed number, you can, but 70 39ths. Graphing that, an open circle at 70 39ths, going left. Okay. What number would you like to use to check this? 0? If we use 0, should that work? Yes. 0 in this case is over here, right? It's part of our solution set. So if we have 0 divided by 5, excuse me, that's going to sound horrible on the recording. We have 0 divided by 5 greater than 8 times 0 minus 14. 0 divided by 5 cancels out to be 0. 8 times 0 cancels out, and we're left with negative 14. Is 0 greater than negative 14? Yes. And so we've been confident that we are good to go. Okay. Questions on any of this so far? No? Excellent. All right. Like we saw with equations also, we do have those times when we get either no solution or all solutions. And we see that here in these situations. So this first one, 8n minus 4 is greater than 8n plus 7. What about that inequality clues you into the fact that it's going to be either no solution or all solution? Gabby?
On either side there is an 8n, and so if you subtract one of them, it would just kind of cancel the other one out.
Exactly. We have the same number of n's on both sides, which means that when we subtract 8n from one side to move it over, we're just subtracting 8n from the other side, and they're both going to cancel out. Okay? That will always happen when you've got the same number of variables on both sides. And so what we're left with is the inequality, negative 4 is greater than 7, which is not true. Therefore, no solution. Okay? Just like we saw with the equations, if the equation is not true, it's no solution. If the inequality is not true, there's no value for n, then when you plug it in here and subtract 4, but then on the other side add 7, that the left side is going to be greater than the right side. Okay? The second one, where you've got 3n plus 2 plus 4n, that can be simplified by combining like terms to be 7n plus 2, which is less than or equal to 7n plus 6. Again, we have the same number of n's on both sides, which means these are going to cancel out, and we're left with 2 is less than or equal to 6. True or false? True. 2 is less than or equal to 6. Therefore, we have that cool-looking double R symbol to show that any number, this is an infinite number of solutions, any real number is going to make this inequality true. Because whatever n is, we multiply it by 7 on both sides, so that's the same. But then on the left side, we add 2. They'll always be less than if we were to add 6. Okay? Thanks. Good job for you, too. Let's go to the second page here. Any of these 6 that you would like to take on together? I'm willing to embrace the struggle with you all.
What? You don't know how to do this either? That's it.
Yes. No, I'll be experiencing it with you.
So you haven't done.
I already got one answer wrong today, so you know.
You're gonna fail the test.
You're not going to fail the test. Ready? Bottom left. Negative 8 minus 1 divided by 23 is less than or equal to 1. All right. Let me scroll down here a little bit so we can get that. Okay. So I take a look at what I have here. I see that fraction. And so my first thought is, how can I unfractionize that? What do you do to undo or get rid of that fraction? And if you're unsure, flip back to the first page because we had one kind of similar to this there. Brent. Multiply both sides by 23. Okay. And on the left side, that's really nice because all that does is, you know, since multiplying is the opposite of division, that's going to cancel out the denominator. I don't have to distribute. I don't have to do anything there. I'm just left with that negative 8n minus 1. And on the right side, since I only have that 1 times 23 is 23. Again, don't have to distribute, do anything there. So in one step, I'm now in an inequality that I hope you're much more comfortable with. Recognize it as just your basic two-step. Okay? Start with your constants. Opposite operations. We're going to add 1 to both sides. So negative 8n is less than or equal to 24. Now we care it's an inequality, because in this step, that's where we'll be doing our division. Divide by negative 8. On the left side cancels out. Our inequality symbol flips, becomes greater than, and we get n is greater than or equal to negative 3. Our graph is a closed circle at negative 3 going to the right, and there we have it. Okay? Any others of those 6, the remaining 5 you'd like to do? So, Abby? The next one, very, very good. Okay, so 3n plus 7 plus 4n is greater than negative 3n plus 7 plus 4n. Ooh. Is this going to be a no solution or all real situation here? Thumper? Why? Okay. So my left side, I can rewrite this to be 7n plus 7. And my right side, in my parentheses, I can rewrite that to be negative 7n plus 7. So when I distribute this negative sign in, my left side stays 7n plus 7, but my right side becomes negative 7n minus 7. Well, it's not a problem. It just means that, do we have the same number of n's on both sides? No. So is this going to be a no solution or all solution? No, it's not. Okay? No, it's not. Because we have to have the same number, and 7 is not the same as negative 7. So you might want to add 7n to both sides to move things over to the left here. And that gives us 14n plus 7 is greater than negative 7. Do you have a question? No. Okay. Really, all I did was I combined like terms on the left side, right? 3n plus 4n gives me 7n, then plus 7. On the right side, I combined what was in my parentheses to get 7n plus 7. But then because that negative sign's on the outside, I have to distribute, which really I'm multiplying each thing by a negative 1. So 7n times negative 1 is a negative 7. And then 7 times negative 1 is a negative 7. Okay. Subtract 7 from both sides now at my two-step here. That gives me 14n is greater than negative 14. Divide both sides by 14 to get n by itself. Is the inequality symbol going to be flipping here? No, it's not, because I'm dividing by a positive 14. I get n is greater than negative 1. That's one of those that sets you up to think one thing, but then surprise, something else. Okay. Oh, of course, then the graph of that, open circle at negative 1. Going right. Okay. Questions, comments, concerns, complaints, comments, congratulations, or criticisms on that? Why?
Because I don't understand. Yeah, never mind.
Well, if you just remind yourself that if you think about these as equations, up until that last step where you have to multiply or divide to get n by itself, if you remember how to combine like terms, if you remember how to distribute, if you remember how to do variables on both sides, these are all basically that. Okay? If you don't, then before doing this, you might want to look back at PO10 where things were a little bit simpler because we were first kind of learning those concepts of variables on both sides and everything. Take a look at some of those equations for the process, then come back to CO15 and apply that process to these. Okay? But there really is no new skill being done today. Right? This is kind of just the coming together of several skills that we've done already this unit. Elise? If there's no solution, there's nothing to graph. So no. Okay, same thing for all solutions. So you have the 4 above this for homework tonight. You have the front side, and then you've got the word problems down here at the bottom, 2 of them, I think. So is there one of the word problems you want to talk about? Lucas, do you have another question? Aren't there 4 above here? Sorry, it shouldn't have been. So finish the first page. Finish the 4 that are above the 2 that we worked on. So the second page, and then you have the word problems down below. So let's just look at the first one here. It says the price of gas is $2.25 per gallon, and a car wash is $7.50. A customer who purchases a car wash gets 10 cents off per gallon. Graph inequality describing the number of gallons of gas a customer who also gets a car wash can purchase without spending more than $20. Okay? So this inequality is essentially going to be, your gas plus the car wash. What inequality symbol are we going to be using here if we want to spend without spending more than $20? What inequality symbol would that be? Less than or equal to the total price, which is 20. Okay? So if I'm a customer who gets a car wash, I know that is $7.50, right? That's a constant. That price is the same. Whether I'm buying one, I suppose if you say, well, I want a second car wash, because the first one didn't do a good enough job, then you pay $7.50 again. Okay, but for one car wash, $7.50. How do I represent my price of gas? This situation here says it's $2.25 per gallon, but a customer who purchases a car wash gets 10 cents off per gallon. How's that going to be represented? Ready? Okay, so G can be my gallon. And what's my coefficient to G? I'm a customer who's purchasing a car wash, so I get that discount. What's my coefficient to G? Elise?
Well, you would subtract. So you do $2.25 minus 10 cents.
Which gives me what?
$2.15.
So I'm paying $2.15 per gallon plus my $7.50 for my car wash. And in order to spend no more than $20, solving that inequality will tell me how many gallons of gas I can get. That's for you to do. Okay. In this context, would a decimal answer for a gallon of gas make sense? Yes, because you can get a partial gallon. Right? That's kind of how you think through this to set that up. The next one, you're saving money for summer camp that costs $1,800. You save $500 so far, and you have 14 more weeks to save the total amount. What is the least amount you can save each week and still reach your goal? Okay. So homework is to finish CO15, both the first and second page here, and we'll go over this tomorrow. And that's how you math.